Okay, everybody. Really quick, gonna cover some basic electricity. I see you guys were playing with the apps. Hopefully, you had some fun with that. John Travolta's Gazatch. That's one of my favorites over the years. Kids always like that one. Um, the static electricity balloon charging one. That's a cool one too. So, um, with static electricity, we don't literally see things with like plus signs, right? And minus signs and such on them, right? We don't see that. We just see the objects. But what those plus and minus signs are representing are protons and electrons essentially. A plus sign is an excess proton, right? I'll try to rely on a bit of your chemistry knowledge. A negative sign on one of these is an excess electron, right? P plus sometimes you write it as. It really always is good. Now a couple things right off the bat. Protons can't move, right? So really, when you charge something, you're moving around electrons. You're moving around electrons. Let's talk about what charge is a little bit, and then we'll talk about a little bit more about charging things, how we charge things. So what is charge? Charge is not a thing. We use the word very all around, right? We say, oh, those charges over there. That treats it like a noun, like a thing, right? And then we charge things. We charge things. We charge things like an action, right? But what charge is actually? It's a property of matter. So charge is a property of matter. It helps us predict. What does it do? It helps us predict how something will behave. All right? It's actually a fundamental property of matter. The two fundamental properties are pretty much charge and mass. Charge and mass are pretty much two fundamental properties of matter. So something's mass, right? That helps us predict how something will behave, right? Because of Newton's second law, we know the more mass something has, the harder it is to accelerate. We know the more mass something has, the greater the gravitational force of attraction will be. We know if something has more mass, when it collides in a collision, it's going to have a greater momentum, right? So that property of matter, mass, we can use to predict how things are going to behave. Well, the same thing's true with charge, and it's actually very much like mass. In terms of if you have more charge, if an object has more charge, then it's going to experience greater forces of interaction with other charged objects. If it has more charge, it's going to deliver more electrical energy into whatever it is you're doing, right? So it's very much like mass. And in fact, it's kind of interesting is I don't remember who was a proponent of this, but there was this thought, there were some people who were calling charge actually electric mass. All right? There was going to be three types of mass: electric mass, inertial mass, which is A equals F over M, that's our inertial mass, and then gravitational mass. Right, kind of an interesting thing. Gravitational mass is G M1 M2 over R. It's that mass. Now you might say, what's the difference between the two? This mass, in inertial mass and gravitational mass, nothing. They never have been proven to be experimentally different, right? So there, we just call those two, we just call mass. And then electric mass, they decided not to, that didn't gain popularity, right? So we said, no, okay, we're just gonna leave it charge. Charge and mass. All right, so what is charge? Well, it's it's not a thing. It's a property. What is mass? Well, you know, it's how much something resists change in motion when a force is applied to it. How much it reacts to the force, right? It's a proportionality type thing, right? Charge is kind of the same thing. It's how much something will react to an electric force, so to speak, or an electric field. But we'll get to that later on. What you should realize is one electron carries a charge of -1. And what's the unit on it? Well, I'm going to show you that. It's actually in script E. One proton carries a charge of +1 E. And this kind of script E thing is called a fundamental charge unit. 1E, -1E, fundamental charge unit. Lots of times you don't even write the E. We just say it's +1, +2. Now, I will say later on, we're going to learn another charge unit called a coulomb. A coulomb, that is actually the scientific base unit. It turns out that when we actually talk about charging objects, this number is way too small because we're transferring trillions of billions of electrons when we charge something, right? Like when we rub a balloon on our head, right, and stick it to the wall, there's a transfer of just incomprehensible amounts of electrons, right? It's not like that simulation where it's like 5 electrons going on there and then attracting. It's like, think of it like it's smaller than molecules of water and liquid, you know. I mean, it's just like, it's very hard to comprehend how many electrons are getting moved. Coulomb. And it looks like a capital C. It turns out that 1E is 1.6 times 10 to the minus 19th coulombs. And we'll talk about that later on. So right now we're just kind of we're treating these things like, we're treating these things just like integer charge values, right? So we don't have to worry about the coulombs yet. We'll have to worry about that once we start doing calculations with static electricity. So let's look at that balloon one first, right? Like, you charge up the balloon and it gets all these little negative signs on it. Well, each of those negative signs represents excess positive charge. So only electrons can transfer from one object to another, right? So when you rub the balloon with your hair, like here's your hair, right? Your head, whatever it is, you're actually stripping electrons off of that material onto the surface of the balloon, right? You're stripping electrons off of whatever that is, if it's wool or hair or sweater, whatever. You're actually removing electrons from that material and they're going onto the balloon. So now the balloon has accumulated an excess negative charge, but charge is always conserved. So if this was neutral, right? If you have an object, right, that is, let's say it's neutral. Neutral means if you add up all the plus and minuses, the total charge is 0, right? We have 2 positives, 2 negatives. That's a total charge of 0, right? Let's say you have over here, you have something that is, you know, has, I don't know, just a lot more charge. All right, it's also neutral, right? Let's say like you rub these together and for whatever reason this one takes some of the electrons from this one. Well, all right, so if it takes, let's say it takes 2 electrons from this guy over here, right? So let's say 2 electrons in touching these 2 things together takes 2 electrons. Well, now this one over here has accumulated 2 extra electrons. This one over here has lost 2 electrons. 1, 2, 3, 4, 5, 6. Right? So this one has 2 electrons. This one's lost 2 electrons. This one losing 2 electrons, now that's basically left us with 2 extra positives, right? So, oops, I don't need to draw 2 more. We have 1, 2, 3, 4 electrons now over here. We have 1, 2, 3, 4, 5, 6. So this one's total charge now is positive 2. This one's charge is negative 2. And we don't, when something's neutral, we actually just leave it blank, right? We just leave it blank and we say, okay. We don't try to even out the charge like this, right? So the point of this is when things get charged, it's because they're either gaining or losing electrons from their surface, all right? We cannot pull protons out of, we cannot pull protons out of nuclei. That would be a nuclear reaction, right? It's kind of interesting. So that's just kind of a basic introduction to static electricity, kind of how things flow around. I'm going to go make a second video playing with the apps and kind of talking you through some of the interesting points to observe there. Okay? All right. Have a great day.